Hi, I'm just going to try out one of these cameras and see how this works. My goal is to send some videos for you to use either alone with your child, or you could do it with your child and follow along on these videos. But this is a home connection that'll come home. It's from Unit 1 Module 3 Session 2. The title of it is Multiples, Flowers, and Cards. It's a two-pager. When you look at number 1, it talks about multiples, and really as much as you can, we want to use these words until we are comfortable with them. And here's a great example. When you count by a number, you are naming the multiples of that number. For example, if you skip count by fives, you are naming the multiples of 5. 5, 10, 15, 20, 25, and so on. Those are multiples of 5 because we're counting by fives. So in each sequence below, we're going to fill in the missing multiples. They did the one for us. And we can count by fives and find out that 20 was missing. 35 would have been the next number. Counting by threes, 3, 6, something, 9, 12, or excuse me, I just said the answer. 12, 15, 18, blank, 24. 3 plus 3 is 6. 6 plus another 3 is 9. Hopefully you're filling these in with me because that would be super helpful. Oh, my pen stopped working. Come on. There we go. 9 plus 3 is 12, plus 3 is 15, plus 3 is 18. 18 plus 3 is 21, and then plus 3 more would be 24. Now, if we move down here to counting by sixes, 6 plus 6 is, write it in please, 12. 12 plus 6 is 18. 18 plus 6 is 24. At any point during these videos, if you want to, if I don't leave you a big enough gap, pause it. Just hit pause, okay? Counting by nines. 9 plus 9 is 18. Add another 9, we get, pause if you need to, 27. Plus 9 is 36. 45. Add another 9, you would have 54. And kids are coming in from recess, if you can hear that, the sounds in the background. Circle all the multiples of the number in each box. So, some of these are multiples, so I can take 5 times something and get 20. It happens to be 4, right? I can't take 5 times an even number or a whole number and get 15, so that's not an option. Yes, yes, nope, nope, yes, nope. Okay? Now, if you go across, can I take 2 times the number and get 5? No, I cannot. Can I take 2 times the number and get 6? Yes, I can. I can take it times 3. 7, no. 2 times 2 times 3 is 6. 2 times 4 is 8. Nope, can't get to 7. Oh no, I just did the answer. That's a good one. What about 2 times something is 14? Yeah, 2 times 7 is 14. 2 times something is 21. Well, 2 times 10 is 20. That's pretty close. 2 times 11 is 22. Nope, won't work. And 2 times 5 is 10. When you're thinking about counting by twos, we should note that any number that is even is a multiple of 2. Okay? Let's count by fours. 4 times 2 is 8. What about 6? Nope, won't work. 4 times something is 14. No, can't. That doesn't work out. Let's see. 4 times 4 is 16. 4 times 5 is 20. 28. Does that work? What do you think? If I say that 4 times, I'll write this down here. If I say that 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28. So that one does work. 19 does not work. Here's another pattern. Our multiples of 4 have to be an even number. Can't be any even number, but we know that anytime we see an odd number, that cannot be a multiple of 4. Okay? Let's get a little closer. Now I'm going to let you do the rest of those. If that is not clear, maybe a grown-up could help you with your multiples. you're going to count by sevens to figure out if any of these are multiples of 7. Here you're going to count by eights, 8, 16, 24, 32, right? And see if any of these are multiples of 8. When you get to letter E, you're counting by threes, 3, 6, 9, 12, 15, trying to figure out if any of these are multiples of 3, okay? Filling in the missing numbers, the top row is just a regular times table. Take the top number times the bottom number, okay? On the line below that, it gets a little trickier, right? Because we have all the answers. We have to figure out what's missing. 3 times what is 24? We could guess. What about 3 times 5? Well, that's 15. That's not going to work. 3 times 6 is 18. That's not going to work. 3 times 7 is 21. Nope, that's not going to work. 3 times 8, 24. Ah, that must be the answer. 3 times 8 is 24. In some of these cases, you might have to guess to get close. In others, we should be able to get to the answer pretty quickly, like counting by sevens. How many sevens are in 14? 2 of them. 7 times 2 is 14. How many 5s are in 40? If you counted by 5, 5, 10, 15, 20, 25, 30, you would find that there are 6. Okay? I'm going to let you finish the rest of that page on your own time. When we get to question number 4, we love these word problems. I know some of you don't, but I love that they have lots of information for us to picture and draw. They give you room to draw. Draw if you want. 4 friends were making cards to sell at the holiday sale. So I've got 4. That's an important number to remember. Each friend made 9 cards. So I have 4 friends, each making 9 cards. They put all their cards together and then bundle them into 6 groups of 6 cards to sell. Oh my goodness. How many bundles of 6 cards did they make? Oh my goodness. Well, maybe we could talk about these friends. Okay? There's a friend. Sorry about my drawings. There's a friend. There's a friend. I'm a visual person. I love to see it on paper. That helps me a lot. Each of them brought 9 cards. Now, I could add them together. That would give me an answer. 9, 18, 27, 36. I could also say 4 friends times 9 gives me 36. I get the same answer. Okay? Problem is we want this number of cards. I have 36 cards. Okay, I'll put that in here. We want those split into 6 groups. So I need, if you want to think of it this way, I have to figure out how to get those 36 cards into 6 groups. 1, 2, 3, 4, 5, one more. Okay? How am I going to evenly split up 36? We're going to need to divide. 36 divided by 6 equals the number that we want. Okay? If you can count by 6s, we could get the answer. Maybe we could use a number line. Okay? We could start at 0. Now, we need 6 groups, right? Or we have groups of 6. So if I count by 6s, this should work out really well. Let's do this. 6, 12, 18, 24, 30, 36. Oh, I got it. 6, 12, 18, 24, 30, 36. Yep. How many groups did I just make? Count each hump. What do we get? 1, 2, 3, 4, 5, 6. Oops, that's not a 5. 5, 6. So, each group has to have 6 cards in it. So 36 divided by 6 is 6. I could reverse this and say 6 times 6 equals 36. And my answer is still true, because we can multiply these to get this answer. Now, could I have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 until every group had 6? Absolutely. Is it maybe a little too time consuming? I hope so. We don't have time for this, do we? But if you needed to, you could, just to prove that you were right, and you could put 1 in every individual group to see if you were correct. We could also set up a ratio table if we wanted to. All right? I don't know how many rows we'll need, but let's start there. I could say One group needs 6 cards. 2 groups would need 12. 3 would need 18. 4 would need 24. 5 would need 30. 6 would be 36. Okay, I guess I needed one more row. Okay, and that would have given me the same answer. Okay, because here I'm adding a group, and here I'm adding 6 cards to each group. Okay, get the same answer regardless. Many ways to get the same answer. Now, as I look at this next one, Zach measured a rectangular garden in the park. Ooh, I gotta draw that rectangle because I cannot do these problems without something to look at, okay? The longer sides each measured 15 feet. So I've got longer sides measured 15 feet, okay? And were 3 times longer than the shorter sides. So I've got these shorter sides here. 3 times shorter. So I need to figure out 3 times. So something times 3 gives me my longer wall of 15 feet. I could also think of it this way. I could divide that into 3 smaller pieces, and we're still going to get the exact same answer. And what could that be? Well, 1 times 3 is 3, right? 2 times 3, 6. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. So we know that our answer is 5. Okay? So each one of these sides is 5. Now, if you wanted to double check, 3 times longer than the shorter sides. Is this 3 times longer than that? Yeah. 5 times 3 is 15. We could do a ratio table. We could do a number line to come to the same conclusion. But we are going to just be satisfied with knowing that if we just rearrange our equation, we can multiply to get 15 or divide into 3 shorter bits to get 5. Okay? Now, are we done? Let's look. If Zach walked all the way around the garden, how far did he walk? Okay? So maybe Zach is standing here, and he's going to walk all the way around. In order to do that, we have to add up all the numbers. So I have a 15 and a 15, a 5 and a 5. You could add this way. 5, 10, 15, 20. Carry the 2. 2 plus 1 plus 1 is 4. I could get 40. Sometimes you can make a lot of mistakes along the way. Maybe I do 15 and 15, 5 and 5. Okay? And I get 5 plus 5 is 10. 15 plus 15 is 30. Well, 30 plus 10. That's pretty easy to add. 40. We must make sure we label 40 what? Feet. Where did I get that answer? Measured 15 feet. So we know that our measurement, our units of measure, are feet. I'm going to try to get as many of these out as I possibly can for you, but make sure you go back in and fill the ones that we didn't do together. If you have questions, email me. Come see me. We can always work during our intervention time. Want to make sure that you feel comfy with these concepts, okay? I'll catch you cool cats later.